Yes, good morning guys to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. Please tell me, am I properly audible and visible to all of you or not? Yes. Okay, I feel my voice is coming properly. Yes, Vinay, good morning. So guys, first of all, happy Dussehra to all of you as today is festival and we are here for this session. Okay, I feel I need to make volume lesser. Fine, guys. So as you know, we were going for the matrix algebra and we started in the last class. This is the second part. So today, what are the things we are going to discuss? So guys, today, first of all, we have already completed the determinant part. And today we will be talking about the matrices, type of matrices. And then we will see about the inverse of a matrix. And after inverse, we will be going for rank of a matrix. So till this point, we will try to complete today. Yes, Dia, good morning. So moving further, guys, this is some detail about me. And this is the link of Telegram channel Mechanical by Dheeraj Sardana, where you will get the PDF of this session. And guys, now we are also announcing one more thing, that is mega mock challenges are started now. The full length tests which are free from BYJU'S exam prep for all the students. So guys, now for you can see 28th October to 4th November will be the second mega mock challenge. Okay, and this will be of obviously 3 hours, 65 question, 100 marks. For different branch, different syllabus is there. Like for mechanical and civil, for mechanical, fluid mechanics, SOM and power plant will be there. So likewise for other branches, if you want to see, it is available in the app and the link of this app is there in the description. So you can join that, okay? And then my dear, there is a series starting from 25th of October, that is formula memory, where we will be having the questions in terms of formula. You need to choose which question is going to use which formula, okay? Nishant, good morning. So guys, now without wasting the time, we are starting with the types of matrices. So my dear, like we have seen the types of determinant, right now we are having the types of matrices. So guys, these are the specifically 8 types we are going to talk about: row matrix, column matrix, null matrix or zero matrix, diagonal matrix, upper triangular, lower triangular, submatrix and equal matrices. So one by one we will see. When we are talking about row matrix, you know, we are calling a matrix as row matrix if it is having one row and n number of column, like maybe 1, 2 and 3. This is a row matrix where number of row is 1, number of column can be any number. And then we are having the column matrix, like we have this 2, 3, 4. Here you can see it is having one column but n number of rows. Such matrix is said to be the column matrix. I will also give you the shortcut for finding out inverse today, okay? Then my dear, next is null matrix or zero matrix. So when we are talking about null matrix or zero matrix, first of all, it is a square matrix. Okay, first of all, it is a square matrix. And when we say square, it means the number of rows and number of column will be equal. And if I am saying that m is equals to n, so my dear, all the elements also will be 0. All elements are 0. Then we call it as null matrix. So like if I want to write a matrix of 2 cross 2, which is a null matrix, I will write it 0, 0, 0, 0. Okay, similarly, if I want to write a null matrix of 3, 0, 0, 0, 0, 0, 0 and 0, 0, 0. So guys, please tell me, am I properly audible, visible? aa raha hai samajh sabhi ko? Yes, I know these things are easier, but guys, as I promised you to teach everything, so we are going for everything. Okay, is it clear? Is it clear, guys? Yes, Vinay, Divya, Dia, Nishant, aspirant. So guys, now we are moving for the diagonal matrix. When we are talking about diagonal matrix, then my dear, you know that I already told you when we were discussing about the determinants. So if we are talking about these 3 elements, these are the 3 principal diagonal element. So other than these elements, all will be 0. Other than these elements, all will be 0. And also when we are talking about these principal diagonal element, they all should not be 0. Okay, Like when we talk about A, B, C, maybe out of these three, two can be 0. But all three should not be 0. Okay. So that is the condition for diagonal matrix. Then we are talking about diagonal matrix. After that, we have upper triangular matrix. So when we are talking about the upper triangular matrix, that also you know, like if these are the principal diagonal elements, and upper to this is, let us say, D, E, F. So you know, other than this, all elements are going to be 0. This we have already seen in the determinant also. It is also going to be a square matrix. This is also a square matrix. So when we are talking about this, these are the principal diagonal elements. Principal diagonal elements and elements above this, all should not be 0. Okay. And rest all should be 0. That is the condition for upper triangular. And lower triangular is going to be just opposite to that. Like you have the principal diagonal elements as A, B, C. And here we have D, E, F, and all other elements must be 0. So here we can say the principal diagonal elements and elements below this should not be 0, should not all be 0. Means it can be like out of these 3, 4, 5, 6, maybe 4 elements are 0, but all 6 should not be 0. That is the condition. Okay. So this is said to be the lower triangular matrix. Then my dear, we have submatrix. Then we have submatrix. So my dear, like if I am writing a matrix 1, 2, 3, 2, 3, 1, 4, 5, 6. So my dear, if I delete some of the rows and some of the columns of this matrix, like if I am saying that I am deleting this row, this column. So I would be left with 1, 2, 2, 3. So this is going to be a submatrix. Okay. So if I am going to, let us say, delete this more row, you would be having one more matrix, 1, 2. This is also a submatrix. Okay. Aspirant, this is not minor. Yes, you are saying that minor also we will deal in that way. So if we are talking about I am deleting this also, then we are having this as a submatrix. So you can see a submatrix is the part of this matrix which we will be obtaining by deleting some of the rows or some of the column of a given matrix. Okay. Yes, in the terms of minor we will see aspirant. Actually, when we talk about the minor, it is said in terms of determinant. Okay. So that also we are going to see. First of all, tell me, is it clear? Light to nahi aa rahi hai? Let me do this. Is it clear now? Sahi dikh raha hai sab kuch? Yes. So moving further, guys. After submatrix, we are talking about the equal matrices. So my dear, if we have a matrix A with I number of rows, J number of column, it will be equals to a matrix B, I number of rows, J number of column, only when all the elements, all elements are equal. Okay. If even one element is not equal, matrices are not said to be equal matrices. So equal matrices means when all elements of one matrix are equals to the all elements of second matrix individually. And obviously their number of rows, number of columns, they all will remain the same. So my dear, this is the definitions. Now we are moving to some important things. Okay. That we are going to utilize while finding out the rank, while finding out the inverse of the matrix. And then only we will be able to do the system of linear equations and eigenvalues and eigenvector. So after this, one more session would be required for matrices and one practice session we will be having for 50-25 like questions. So my dear, now we are talking about identity matrix. Identity matrix is a square matrix. So if it is a square matrix, you know that the number of rows, number of column are going to be equal. And all the principal diagonal element are going to be equals to 1. So my dear, if we are going to write a 2 by 2 identity matrix, it is a square matrix. So diagonal element will be 1 and other elements will be 0. And we will denote it as I2 cross 2. Or we can also write it as I2. Because it is square matrix. Then my dear, we can also write 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is going to be I3. Is it clear or not? So my dear, the symbol given is either IN cross N or IN. This is the symbol for identity matrix. Then my dear, there are some properties of identity matrix. that whenever you will be going for determinant of identity matrix, it will be coming out to be 1. When you will be multiplying any n number of identity matrix, you will get once again the identity matrix. If you will take inverse of identity matrix, you will get identity matrix itself. When you will multiply any matrix with identity matrix, you will get that matrix again. So these are the very common properties which we are using for this identity matrix. We will be utilizing them again and again. They are easy things. That's why I'm going slightly faster. And that's why I have these things written rather than I am writing by myself. Next matrix is, my dear, scalar matrix. So like you have seen, if we are having a square matrix, let us say of 3 cross 3. And this time we are having the diagonal elements all are equal, but they are not equals to 1. Let us say they are equals to some number 4. 4, 4, 4. And rest are 0. Then this matrix will be said to be the scalar matrix. So when all the principal diagonal elements are equal, but they are not equals to, I am not saying they are equals to 1. If it is equals to 1, it will become identity matrix. So you can say identity matrix is also a scalar matrix. Yes. But my dear, when we are saying scalar, this number can be any constant. It can be 1, 2, 3, 4, whatever it is. So you also know, like I can also write this matrix as 4 into. Then it is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Can we write it like that? Can we write it like that? Because whenever this number is taken common from all the elements, it will become identity matrix because all others are 0. So we can also write it as 4 times of I. So my dear, similarly, if that constant is k, then my dear, a matrix which is k into A can also be written as, okay. So when we are talking about the scalar matrix, my dear, I would like to say one thing here. If you remember when we were talking about the determinant, then determinant we were taking common from one row or one column. है ना? So if we are going to talk about the determinant of this scalar matrix, then my dear, what it will be? Like if you want to find out determinant of this matrix A, which is a scalar matrix like that, then my dear, for that, if you are going to take 4 as common, then my dear, 4 will be coming common from all the rows or columns individually. So you would be having 4 की power 3 into determinant of identity matrix. But when we are writing in form of matrices, then we can write A is equals to 4 times of identity matrix. So can you feel it? If that constant is k, I am going to generalize it. I will be generalize it like this. Like a scalar matrix can be written as k times of identity matrix, but determinant of this can be written as k to the power n if order of the matrix is n. Everybody is getting it or not? Yes, Papa ka ghoda. Please tell me everybody understood this or not. Everybody understood this or not? Good morning, good morning. So dear, that is how we are going to move ahead. So guys, do like and share the session. I am going slightly faster here because I know you guys are very well aware of these things. You have studied in 12th class as well. So I am going slightly faster here. Okay. So I feel you guys are getting it. Am I correct? Yes. So guys, now we are moving further. Okay. So now we are moving further, guys. Fine. Yes, Jamit, how are you? Moving further, guys, now to the addition of two matrices. So my dear, like you have seen, whatever the types of matrices we have seen till now, if we accept row and column matrix, whether it is diagonal, upper triangular, lower triangular, or you can say scalar matrix, identity matrix, they all were square matrices. Okay. But whenever we are talking about addition of matrices, then you can have the addition of rectangular matrices also and addition of square matrices also. Okay. But obviously, if you are going to add two matrices, their order should be same. So like if you are going to add two rectangular matrices, the result will also come as rectangular matrix. If you are going to add two square matrices, the result will also come as square matrices. And you know, like if we are going to have A, B, C, D, like this, if you are going to add here E, F, G, H. So you know, after addition, what you will do, this element will be added to this A plus E. Next will be B plus F. Okay, next will be C plus G. Next will be D plus H. So likewise, we are going to do the addition of the matrix. So it is different than the determinant properties what you have seen. Okay. So there we are dealing with differently. Here we are dealing with differently. That's why we are talking about each and everything again here. This is said to be the addition. Okay. Then my dear, we are talking about the properties of addition. Like if we are writing A minus B, it can also be written as A plus of minus B. Then my dear, the addition is commutative in nature. Means like we are saying A plus B is B plus A. Similarly, if we are going to add A and B first, after that we are adding C into that. Or you are doing B plus C and then you are adding A, it is going to be same. Then my dear, A plus B and A plus C, if they are equal, then you can cancel A and you will get B is equals to C. Then my dear, if you are going to add null matrix into a matrix, then you will get the matrix itself. And if you are having a matrix C is equals to matrix A plus matrix B, then determinant of C will be equals to determinant of matrix A plus B. But you cannot write it as determinant of A plus determinant of B. So mind this thing, this is a very, very important point I wanted to tell you here. Is it clear? Yes. So it is associative, it is commutative. Then we are moving to the multiplication of matrices. And don't worry, after that the concept of inverse will be coming. So don't worry, we are coming into important and interesting part very soon. So when we are talking about the multiplication of matrices, then my dear, like when we were having addition, for multiplication, all the time maybe multiplication of the matrices not be possible. Like if you are going to have a matrix A, M cross N, and you are having a matrix B, P cross Q, then my dear, A into B will exist only if the number of column of A is equals to the number of rows of B. So it is possible only if N is equals to P. Similarly, my dear, B into A will be existing only if the number of column of B is equals to the number of rows of A. So that is how you can have this existence. So my dear, if that is the case, the possibility we have discussed. So when we are having A n cross M, B n cross P, multiplication is not possible. Why? Because this condition must satisfy. So when we are going for A M cross N, B N cross P, you can see the number of columns and number of rows are equal here. Then you can go for multiplication. And after multiplication, whatever the matrix you will get, its order will be M cross P. So this will be the new matrix whose order will be M cross P. Is it clear? So if you are going to multiply the square matrices like that, then it will be a square matrix of the same order. So there is no problem in that. It is the multiplication. Okay. So this is about the multiplication of matrices. We are going to have a very important note point here from which questions can come, and we will start the question on that now. That is properties. If we have a matrix C which is A cross B, M cross N into N cross P, then my dear, you know, whenever I will be going for the multiplication in the matrices, then the total number of multiplication of elements required in multiplication of true matrices, it is simply M cross N cross P. M cross N cross P. You can see M cross N cross P. That is the case. And if you are talking about the total number of addition of the element required in multiplication is M cross N minus 1 cross P. You can have this type of question, and I am showing you one question to make you understand that. These are two matrices. You have matrix A for which there are 2 rows and 3 columns. Matrix B, we have 3 rows and 2 columns. First of all, tell me A cross B, yeah, A multiplication B is possible or not? Can you tell me A multiplication with B is possible or not? It is possible or not? It is possible, yes, because number of column here is equals to number of rows. Now, my dear, first of all, I am showing you how we are going to do the multiplication. I know you are aware of that, how to do that. First of all, you will be multiplying 1 into 1, then 2 into 1, then 3 into minus 1. So what you will get? 1. The row of this will be multiplied by column of this. So 1 plus 2 minus 3. What you will get here? Are we getting 0 here? Are we getting 0 here? Yes, tell me. Then when you will be multiplying with the second, 2 plus 2, 4, it is going to be 4. Yes, you will be getting a matrix of 2 cross 2. Then you will be multiplying this row with this column. 1 into 1, 1 into 1, 2 into minus 1. So are we getting 0 here? Check करो भैया. Yes, check it. मैं अभी आपके सामने मैट्रिक्स बना के कर रहा हूं ये. So when you will be multiplying this 2 plus 1. Are we getting this? Is it correct? So this is what we are getting after multiplication. So if you see the number of total multiplication, what we have done, number of total multiplications. Then my dear, number of total multiplications are m into n into p. So you know what is m? M into n, 2 into 3 into 2. So as Ganesh have already given the answer, answer will be 12. And if you want to find out the number of additions, number of additions is, you know the formula, m cross n minus 1, m cross n minus 1 into p. I feel the answer will be coming out to be 8 if I am not wrong. Is it clear for everyone? Yes, very good Vinay, aspirant, बहुत ही बढ़िया. Is it clear for everyone? Clear for everyone? So this is how these things can be asked from you in the question. I know you guys are champ in multiplication, but still as I am covering all the things, if a student will see the recordings of this session, he can revise properly all the topics. Likewise, we are going ahead. So my dear, here as you know, if A into B is possible, it is not always that B into A will be possible. You may have A into B existing and B into A not existing. That also is feasible. And my dear, multiplication is not commutative. If you are multiplying A with B and then B with A, even this will not exist. So equal होने का तो सवाल ही नहीं पैदा हो रहा. Then associative it is. If you are multiplying B with C and then with A, or you are multiplying A with B and then with C, it will be equal. If the multiplication is existing, okay. Then my dear, distributive is also there. If you are adding B and C and then multiplying it, or you are right multiplying A with B and A with C, if multiplication is existing, then this is also distributive in nature. Then my dear, if you are having a matrix A 1 2 2 1, this is a square matrix, then my dear, you can write A ka square as A into A. But my dear, you know, for multiplication the number of column should be equal to number of row. That's why I am saying this should be a square matrix. So in case of a square matrix, yes, we can write A square is A into A. Similarly, you can write A cube as multiplication of matrix A 3 times. Okay, so for matrix in the square matrix, we can write like this. Everybody is clear for this or not? Please tell me. Everybody is clear or not? Please tell me. Then when you will be multiplying a matrix with the null matrix, you will get the null matrix. If you are multiplying a matrix with identity matrix, you will get the same matrix itself. Whether you multiply it pre-multiplication or post-multiplication, you will get the same matrix. Then if A into B, this is a very important thing I am going to discuss now. My dear, this is a very important thing I am going to discuss now, that if you are having the product of two matrices, A into B as null matrix, then we can have multiple conditions. We can have matrix A to be 0, B to be non-zero. Because if A is a null matrix, you will multiply it with B, you will get the null matrix. Or you can also have B is 0, A is not 0. This can also be the case. Or you can also have both the matrices individually 0. Then also the product will be 0. And the third condition is, if A is not 0, B is not 0, but A and B are singular. What do you mean by singular? Singular means if determinant of A is 0, determinant of B is 0, that means A inverse and B inverse does not exist. So my dear, these are the condition when you can have the product of two matrices to be 0, and these conditions I can derive also, but I know you don't want the derivation at this time. You want a revision. For that purpose, I am directly giving you result. Otherwise, in this PPT, I have done the derivations also. You can see that. So when I will be sharing you the PPT, derivations are also there. Okay, but I feel you don't require that. So this table I have made in front of you. Now, my dear, you have seen that the multiplication of two non-null matrices is a null matrix if and only if both matrices are singular matrix. Is it clear? So I feel all these things, if you would be revising here, it is going to be a quick revision. So whatever matrices you may have studied for 15 hours, we are going to complete in 4 hours. That also with more practice. So that is for revision, it is possible only. Is it clear? So my dear, is it clear or not? Please tell me that. Everybody got it? Yes, when singular matrix, inverse will not exist. Very good, guys. Very good. So here now we have a question. If you see these two matrices, tell me about A dot A into B. First of all, can you tell me, is it a singular matrix? Is it a singular matrix? Can you tell me? If you find out the determinant of A, you will get 0. If you get determinant of B, it is going to be 0. So can I say the product of these two matrices is going to be a null matrix, although individually these matrices are not null. Now we are coming with a very good question, guys. Be ready for that. This is a very good question. This is from a PYQ of GATE only. You can see a matrix A m cross m plus 5, a matrix B n cross 11 minus n, and they are saying A into B and B into A exist. Calculate the value of m and n. So I told you in this session we will go for theory and practice. Today's, I know that many theory things we are going to see, but this is important lecture because I will give you a shortcut for inverse. Yes, try this out and do like and share the session, guys. After this, we are entering in the inverse. Don't worry. You know that number of columns equals to number of rows, because A into B exists. As B into A is also existing, so number of column is equals to number of rows. Solve these two equations, m minus n, m plus n. Solving this, you will be getting, are we getting 3 and 8? Very good. So answers are coming as 3 and 8. Correct. Very good, guys. So moving further now to the inverse of a matrix. So my dear, quickly in 5 minutes, we will see now the inverse and then we will solve the question by shortcut. Okay. And after inverse, we will enter into the rank of a matrix. So are you happy with the way we are going? Fast revision? Is it fine now? That's what you were asking, because last time when I have taken practice session, you said that, sir, take in the form of concept, but go it fast. That was the comments I have seen, and many students also specifically messaged me that. So I am going in that way. For that only I have written all the things on the PPT so that we can go fast. If I will write everything, it will take time. So now we are talking about invertible matrix, or you can talk about inverse of a matrix. So my dear, first of all, to find out the inverse matrix should be a square matrix. And second thing, its determinant should not be 0. It means if determinant of a matrix is 0, we call it as singular matrix. So if determinant is non-zero, it should be a non-singular matrix. So inverse is getting existed only for a non-singular matrix. So if you are talking about inverse, inverse will be existing if the matrix is a non-singular matrix. This is the first thing. And guys, if you are going to multiply a matrix with its inverse, you will be getting the identity matrix. And my dear, A inverse can be denoted like this also or this also. They are same, only they are not different. These are the representation of inverse. Then my dear, if we talk about the property, as I already told you, if the product of two matrices is identity matrix, then my dear, B is going to be inverse of A and A is going to be inverse of B. And if we are going to multiply two matrices and take inverse, it is going to be the product of inverse of two matrices in opposite order. So A into B ka inverse is B inverse into A inverse. Similarly, we can say A into B into C. And if you take inverse of theirs, you will get C inverse, B inverse, A inverse. So this is the property of inverse we are going to use in the questions as well. Now, first of all, I am telling you how we are going to calculate the inverse. First is the normal method which you study in your college, okay, or the school in the 12th class. That you have a matrix which is a square matrix, then only inverse will exist. First, we are going to find out the minor matrix. I will tell you how to find minor matrix. Then we will go for cofactor matrix. After that, you will be going to take transpose, okay, of this cofactor matrix, that will be adjoint of A. Then inverse of A is nothing but adjoint of A divided by determinant of A. So guys, this is what is going to be the procedure. First of all, we will going for minor, okay. Then we are going for cofactor. Then we are going for adjoint. And then we are going for inverse. This is a 4-step procedure. So one by one, we will be understanding this with the help of a question now. If we have a question like this, you need to find out the inverse. So first of all, I am telling you how to get the minor. So you would be writing, this is matrix A. We are going for minor now. How we will be finding out the minor? I am telling you. This is the minor matrix. So if you want to write down the minor matrix, how you will write? First of all, you will be hiding the first row and first column. What we are getting? 3. So you will write here 3. Okay. Then my dear, if you want to write the second element, you will be hiding this and this. This and this, you will left with -1. Then you are going to hide. Are we getting it or not? Are we getting it or not? So whenever we are going to write the third one, you will be hiding this. You are left with -2. Similarly, when you will be hiding this, you will left with 1. Everybody got it? This is going to be the minor matrix. Yes. Then if you want to make the cofactor of this, then my dear, for cofactor, Cij is equals to -1 to the power I plus j of Mij. Means what you need to do here, you know, this position is first row, first column. So you will say -1 to the power 1 plus 1 into 3. Then here -1 to the power first row, second column, 1 plus 2 into -1. Then my dear, it is going to be -1 to the power second row, first column into -2. Then we are going to have -1 second row, second column. You will be having 1. This will give you the cofactor matrix. So the cofactor matrix is -1 ki power 2 is +1. -1 ki power 3 is -1. -1 ki power 3 is -1. -1 ki power 4 is +1. Is it correct or not? Please tell me. Is it correct or not? Please tell me. Is it correct or not? Please tell me. This is the cofactor one. Then my dear, you are going to make the adjoint of this. For adjoint of A, you would be taking the transpose of this. When you will be taking transfer, row will become column, column will become row. So it will be 3, 1, 2, 1. So this is the adjoint of A. This is the adjoint of A. Now my dear, if you find out determinant of A, our work is over. This is 3 minus of 2. It is coming out to be 5. So my dear, A inverse is 1 by 5. Adjoint is 3, 2, 1, 1. Understood or not? Please tell me that. 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 So guys, this is the normal way to do. We have first find out the minor matrix. Minor is different, minor matrix is different. This is minor matrix. This is cofactor matrix. And then we have adjoint of A, and then we have inverse of A. Now this is the conventional way. What is the shortcut? What is the shortcut? So guys, if we are having a matrix A, B, C, D, then the inverse of this matrix is going to be 1 by determinant of A into DA minus B minus C. Clear? Clear for everyone? Clear for everyone? This is going to be the shortcut. Everybody understood? The shortcut for 2 by 2. Vinay, Dhanesh, aspirant, Jamit. So you just need to interchange these elements and multiply this and this with -1 and multiply it with the determinant of A. This is the shortcut. Then my dear, we are going to have this matrix. So you can apply the shortcut now. Find out this first and then tell me the inverse. I feel it is very easy now. Is it clear? So when you will be finding out the determinant, 6 2 ja 12, 3 4 ja 12. So it is going to be 0. So A inverse does not exist. Okay. So take care of this. Here A inverse will not exist. Why? Because determinant of A is coming out to be 0. Okay. But this is how we will be using the shortcut. Now you can tell me. Find out the A inverse. Yes. So guys, do subscribe the channel if you have not done yet, so that you get all the updates. And on the app also, free quizzes, free mock tests are going on. You can download the app from the link given in the description of this session. Tell me guys, what would be the answer? This time when you will multiply 4 minus 6. 4 minus 6, are we getting -2? This is 4 minus 2 minus 3, 1. Yes. Is it clear? Everybody understood? Please tell me that. So it will be coming out to be -2 plus 1 plus 1.5. Very good, guys. So guys, now we are moving to the 3 cross 3 matrix. Okay. So when we are going for 3 cross 3 matrix, I will be showing you with respect to with the help of a question. So you tell me guys, shall I directly go for shortcut for 3 cross 3? Shall I directly go for shortcut for 3 cross 3? Let us say I am having a matrix 0 1 3. I am writing a known matrix so that we can compare the answer, and it is 2 3 1. We are going to find out the inverse of that. Okay. So my dear, do you remember I have told you a shortcut to find out the determinant? For finding out determinant, what you were doing? 0 1 3, 1 2 1, 2 3 1, and you were repeating the next two rows, 0 1 3, 1 2 1, and then I told you to find out the determinant, you are going like this first. It is coming out to be what? 0. So it is coming 0 plus 9 plus 2. Then minus. Then you were going like this. 3 2 ja 6, 6 2 ja 12. Then 3 0 1. So you are going to get 11 minus 13 minus 2. Am I correct? So after getting the determinant, what you need to do, you need to repeat this and this entire row. 0, 1, 2, 0, 1. 1, 2, 3, 1, 2. And after doing that, you just need to hide first row, first column. And now when you are writing A inverse, it is going to be 1 by determinant of A into. We are going to expand 2 by 2 determinants here. And after expanding, we will be writing vertically like that. Just look at me. I am taking some different color to give you a feel. So can you feel this is the first? If you're writing it 2 minus 3, this is the first element. 2 minus 3 is minus 1. 2 minus 3. Then my dear, next you will take this. 9 minus 1. 9 minus 1. 9 minus 1. Are you getting it? 9 minus 1. You will write vertically, you are expanding horizontally. Then next element will be this. 1 minus 6. 1 minus 6. This is how you are going to use it. Okay. Now my dear, next will be this. 2 minus 1. 2 minus 1. Next will be this. 0 minus 6. 0 minus 6. Next will be this. 3 0. Next will be this. 3 minus 4. 2. And last will be this. 0 minus 1. Is it clear or not? Please tell me that. Clear or not? Please tell me that. I feel this is 0 minus 6. Rest is correct. Clear? Ha. You are correct, Ganesh. Sorry, aspirant. Is it clear? Everybody understood the way, the shortcut to find out the inverse? Please tell me that. Abhinay, are you saying that I shall repeat this shortcut? Are you talking about repeating the shortcut? Then don't worry, next question we are going to do the same. Abhinay, I am saying you that what you need to do, first of all, you need to find out the determinant. How we have found out? Okay, no issues. Then in the next question we will see again. Because repeating means deleting. Okay, so better we will see the same in the next question. Let us see this question now. We are going to repeat the procedure. First of all, we will find out determinant. How we will find out determinant? 1, 2, 2. You will write first column. 2, 2, 2, second column. Then 2, 2, 1, next column. So my dear, first of all, to find out determinant, I told you that write down the first two column again. 1, 2, 2. 2, 2, 2. Okay. So when we are writing this, now my dear, we would be multiplying like this. You are getting 1 into 2, 2, 2 into 1, 2. Then 2 into 2, 4 into 2, 8. 2 into 2, 4, 4 into 2, 8. Minus 2 into 2, 4, 4 into 2, 8. 2 into 2, 4 into 1, 4. 1 into 2 into 2, 4. So what you are getting? 16 plus 2, 18 minus 16. Is it correct? Very good. So Abhinay, till this it is clear? Till this it is clear, Abhinay? Okay. Now what we are going to do, we found out this determinant. Actually, I have done a thing that I should not find it here. So I am deleting it, but I feel everybody knows the determinant will be coming out to be 2. So why I am deleting? To find out the inverse. So we found determinant as 2. Fine. Now you will repeat the first 2 rows here. 1, 2, 2, 1, 2. Second row is 2, 2, 2, 2, 2. You have repeated it. Now, my dear, you would be deleting the first row and first column. And now you want to write down the A inverse. You will say 1 by determinant of A. Now you will be expanding them horizontally and writing the elements vertically. Just look at it. First, you will take this one. This is 2 minus 4. You will write minus 2. Then next element you will do this. 2, 4 minus 2. You will write vertically. The next element is 4 minus 4. Is it clear? Aspirant, whatever I have written is correct? Please tell me. Minus 2, 2, 0. Very good. But then you are going for the second. Then, my dear, you are going for the second with the different color I am showing you. Let us say this one. This will be the next. 4 minus 2. Then 1 minus 4. Then 4 minus 2. Then 4 minus 4. Then 4 minus 2. Then 2 minus 4. Understood? Yes. Abhinay, got it? Aspirant, Vinay. So this is the shortcut to find out the inverse. So now can you do by yourself? Can you do by yourself? Easily? Okay. So my dear, can you do this question by yourself? Can you try this question by yourself? This is the one question you will try by yourself. And after that, we are moving further. Okay, don't worry. So, you know what you need to do? You do by yourself. I am doing here for myself. First of all, we will find out the determinant of it. So, you will put 1, minus 1, 0. 2, 3, minus 2. Minus 2, 0, 1. 1, minus 1, 0. 2, 3, minus 2. And we need to find out the determinant here. 3. Zero. Then 0, 0, minus 2. But you are getting determinant as, are we getting 1? Yes. Now you will repeat the first 2 rows completely. 1, 2, minus 2, 1, 2, minus 1, 3, 0, minus 1, 3. Then you know we are going to write A inverse 1 by A determinant. We are going to expand horizontal and write vertical. Okay. First row, first column. This will be the first element. 3 minus 0. Next element. 0 minus 1. This is 2. Yes. Can I write directly? Match the answer. Yes, now it is clear. Now it is clear. Yes. So guys, now we are entering into the next topic. Is it clear now? Shall we move on now? We completed the inverse. Now we are going for symmetric, skew symmetric, orthogonal matrix. And then we will start the rank of the matrix. Okay? Yes. Answer, Vinay, is this. Yes. So guys, how many of you were not aware of this shortcut before? How many of you were not aware of this shortcut before? Or this is something which I have told you, you were knowing? That's great. Great, great, great. Okay. So don't worry, we will try to have all these things throughout so that you learn these things every time whenever we are coming to such classes. Okay. Fine, guys. So let us move to the next. Next is symmetric and skew symmetric matrix. So my dear, when we are talking about the symmetric and skew symmetric matrix, symmetric matrix is that matrix which is the square matrix. Obviously, you know, every time we are taking the square matrix, and where matrix and its transpose are equal. Matrix and its transpose are equal, and when you will subtract matrix from its transpose, it will be coming 0, obviously, when they are equal matrices. So this is said to be symmetric matrix. These are the example. If you say this is A, what will be A transpose? A transpose will be coming same. You will have 1, 2, 2, 1. Okay, if you are going for this A transpose, once again you will get this A transpose, once again this will get. So all these three matrices are symmetric. All these three matrices are symmetric in nature. Okay. Then my dear, we are having skew symmetric matrix. So when we are talking about skew symmetric matrix, it is also a square matrix. But for this, A transpose is equals to minus of A. And my dear, whenever we are talking about this, obviously this time the summation of A and A transpose will be 0. And my dear, for a skew symmetric matrix, principal diagonal elements are always 0. Then only it is possible to have. And my dear, one more thing is the sum of all the elements is also 0. So these are the properties which will help us to identify whether a matrix is symmetric or skew symmetric, because in the question examiner is asking this type of thing. Okay. So be ready for that. Then my dear, if we have this matrix, this is the example of a skew symmetric matrix. Okay. Like you can see that principal elements are 0. The summation of all elements are 0. and when you go for A transpose, you will be getting 0, 2, minus 2, 0. Okay, so you can see this is nothing but minus of A. So when you will be adding A transpose plus A, it is coming out to be 0. Clear for everyone? Please tell me that. Okay. Yes. Next, let us move further. This is one more case, my dear. Here, this is a 3 cross 3 matrix. If you see, all the principal diagonals are 0. You can see one thing, like this is minus 3, this is 3. This is minus 4, this is 4. This is minus 6, this is 6. Obviously, this will happen. Then only it can be a skew symmetric. So, summation of all elements is 0. Okay. And my dear, if you see the A transpose, once again, you will be getting 0, minus 3, minus 4, 3, 0, minus 6, 4, 6, 0. You can see this is once again nothing but minus A. So in every case, you can identify this. Then my dear, here I would like to tell you one more thing. Here. Like my dear, if we are going to say there is a matrix A, which is a skew symmetric matrix. Then my dear, if you are taking the power of this matrix n, and let us say if n is even, then this matrix will be symmetric. And if n is odd, then this will be skew symmetric. Is it clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Yes. Everyone. So here what we have seen, I said if A is the skew symmetric matrix, you are going to do like A square, A cube, A ki power 4, A ki power 5, that kind of thing. Then this matrix ka square, if n is even, it will be a symmetric matrix. And when you are going to take the power to be odd, it will be a skew symmetric matrix. So this is when you are going to take the power of a matrix like square, cube, 4, that kind of thing. Okay, so this is a property which also will be utilized again and again. And also one more thing I would like to tell you, like if you know that A is a matrix of n cross n. If this n is odd, you will find the determinant to be 0. And if this n is even, you will find this determinant to be a perfect square. I am showing you, don't worry. Yes, very good, very good. So Mini Minds TV, you understood or not? Please tell me. I am showing you this with the help of a matrix. Let us say we have an example. I need to add the slide here. Just give me some time so that I can clarify you this thing. New slide. Okay. Let us say we are having a matrix. Zero, 2, minus 2, 0. This is a skew symmetric matrix. You tell me what is the order of this matrix? The order of this matrix is odd or even? Even. So can you find out the determinant of A? 0 minus of 4. Isn't it 2 ka square? Isn't it 2 ka square? So it is a perfect square. Okay. Likewise, if I am having a matrix 0, 3, 4, this is a skew symmetric matrix. 3 cross 3. Order is 3. Can you find out determinant of this? Tell me, are you getting 0 or not? Solve it and get the answer. Yes. Clear? Clear for everyone? Clear for everyone? Yes. Okay. So guys, I feel the time is over for today. So shall we start the rank on the next class? Because if we will start rank now, it will take 1 more hour. So shall we go for rank in the next time with the system of equations? Or you want to continue? Because today the Dashera is there. I can see watchings are also reducing because people are going for the festival and all. Okay. So please tell me, are you getting something new from this series? Is it useful to you? Are you happy with the content we are going ahead? Please tell me that, so that we can go ahead in the same way. Yes. So the last we will be completing with one more thing. Okay. That one more thing is generally skew symmetric matrix. Like if I am having this A11, A12, A21, A21. Generally skew symmetric matrix are in the form of I to the power n minus j to the power n. If you want to see that I to the power n, g to the power n, you can take I ki power 1 minus j ki power 1. Then you will be finding out the elements. Like when I is 1, j is 1, it will be 0. When I is 1, j is 2, it is minus 1. When I is 2, j is 1, it is 1. When I is 2, j is 2, it is 0. This is a skew symmetric matrix. You can also make a matrix I ki power 2 minus j ki power 2. You can see when I is 1, j is 1, it is 0. When I is 1, j is 2, 1 minus 4, it is minus 3. Okay. When you will be having I to be 2, j to be 1, 4 minus 1 is 3. Then you have I will be 2, j will be 2, you will be getting 0. So you can make any skew symmetric matrix in this way. Okay, I to the power n minus j to the power n. This is the last thing I wanted to say. This PPT will be available on the Telegram channel Mechanical by Dheeraj Sardana. Good afternoon, Zakhmi Atma. So you came at the end of the session. Okay, and then any matrix A can be written in the form of a symmetric and a skew symmetric matrix. A is A plus A transpose by 2 will be a symmetric matrix. A minus A transpose by 2 will be a skew symmetric matrix.